All right, so we are going to talk about horizontal asymptotes and the three different types of a horizontal asymptote. So horizontal asymptotes are your end behavior when x goes out to infinity and when x goes out to negative infinity. So if you were to look at a graph, what happens when x goes to infinity and what happens when x goes to negative infinity? And so we'll talk about the function following one of our basic parent graphs. So maybe it follows a line like y equals 1, or maybe it's going to follow a function like y equals x, or maybe there is no horizontal asymptote. So here are the three things that we want to look for. The first thing is if in your function, let's say we have f of x equals, let's say x cubed plus 4x over, let's say 2x cubed minus 3. Let's say this is our function. So what you want to look for is you want to look for the degree of the leading coefficients in the numerator and the denominator. So our leading terms, x cubed and x cubed. So if they are the same degree, then what you do is you take the coefficients out front, and that is your horizontal asymptote. So remember, there's a secret 1 out front there. So your horizontal asymptote in this case is y equals 1/2. So on your graph, when you go to graph this function, what you can do is at 1/2, you can put a little dotted line, a nice horizontal dotted line, so that you know your function when it goes out to infinity and negative infinity for your x's is going to follow that line. Now, in between there, your function could cross that horizontal asymptote as many times as it wants, because all we're talking about is end behavior. And so we're not talking about like a vertical asymptote that would produce undefined or something like that. So we're just talking about end behavior. So it's going to, in this case, follow the line y equals 1/2. Now, your second scenario, maybe your leading term in the denominator has a greater degree. So let's say you have x squared plus 4, and then in your denominator we have x to the 4th plus 3x minus 2. All right, so that's our function. So again, think about this is end behavior. So if you were to plug in really, really large numbers of x, like 1,000, and then 10,000, and then 1,000,000, what is going to take over? Well, your largest terms are going to be the ones that take over. But think about x squared over x to the 4th. Which one is going to take over when you're plugging in such large numbers of x? And that's going to be your denominator. So your denominator is going to take over. So think about you go from 1/2 to 1/4 to 1/8 to 1/16 to 1/100th to 1/1000th. What are you getting closer and closer to? You're getting closer and closer to 0. So your horizontal asymptote in this case is y equals 0. So same thing as in this first scenario, the first case, you're going to be following a horizontal line for end behavior. And it's just going to be y equals 0. So you could put like a little dotted line after your axes ends, showing that you are going to follow that when x gets very, very large. So those are our first two cases. And those are kind of the easier ones to identify. So you're looking at exponents. If they're the same exponents for your leading terms, you take the coefficients out front. If the exponent is larger in the denominator, your horizontal asymptote is y equals 0. But what happens if your exponent is larger in the numerator? So maybe you have x to the 4th plus 4x all over x cubed minus 2x plus 1. Well, again, think about this as n behavior. So if you're plugging in really, really large numbers of x, your numerator is going to take over. And it's going to go off to infinity or negative infinity, depending on your coefficients out front. And if you're talking about x going to infinity or x going to negative infinity. So for right now, we are just going to state that it is a slant asymptote. So it's a slant asymptote. It's actually going to follow some basic parent function, and we'll talk about how to find that in another video. So these are your three cases. Exponents are the same. Take your leading coefficients. That's how you get the horizontal asymptote. Exponent is larger in the denominator for the leading terms. Then your horizontal asymptote is y equals 0. If your exponent is larger in the numerator, then we are just stating it's a slant asymptote right now, and we will look at how to figure that out in the next video.